The genius of waterless hydro energy storage, rethinking energy storage as the world pivots towards renewable energy sources. One of the critical challenges we face is finding efficient, scalable, and sustainable methods of storing energy. Traditional hydroelectric power, leveraging the gravitational force of falling or flowing water, has long been a reliable method for generating electricity. However, the dependency on vast amounts of water, large reservoirs, and specific geographic conditions limits its applicability. Enter waterless hydro energy storage, a groundbreaking concept that reimagines the mechanics of hydroelectric power by eliminating its reliance on water, opening the door to new possibilities in energy storage. From water to solid mass at its core, waterless hydro energy storage involves substituting water with solid masses, such as concrete blocks, heavy weights, or even earth materials, to store and release energy. The concept is elegantly simple yet profoundly effective. Instead of pumping water to a higher elevation to store energy, massive weights are lifted to a certain height. When energy is needed, these weights are allowed to descend, driving a generator and converting the potential energy into electricity. This concept operates on the same fundamental principles of physics that govern traditional hydroelectric systems. Potential energy stored in an elevated position is converted into kinetic energy when the object is allowed to fall. The primary difference is that this system does not require water or the extensive infrastructure associated with it. A new era of flexibility and sustainability. Geographic independence. Unlike conventional hydroelectric systems, which require specific geographic conditions such as rivers, dams, or large water bodies, waterless hydro systems can be installed almost anywhere. The only prerequisite is the availability of space to operate the lifting and lowering mechanism. This geographic flexibility means that regions previously unsuitable for hydro energy storage can now harness this technology. Reduced environmental impact. Traditional hydroelectric power plants often have significant ecological footprints, including the displacement of communities, disruption of aquatic ecosystems, and alteration of natural water courses. Waterless hydro systems, by contrast, avoid these issues. They do not require damming rivers or flooding valleys, making them a much more environmentally friendly option. Scalability and modularity. Waterless hydro systems can be scaled to fit the energy storage needs of a given area. They can be as small as a single system for a microgrid, or as large as a sprawling installation capable of storing gigawatt-hours of energy. Additionally, these systems are modular, allowing for incremental capacity increases as demand grows. Durability and longevity. The materials used in waterless hydro systems, such as concrete or steel, are highly durable, with lifespans that can extend over several decades with minimal maintenance. Unlike batteries, which degrade over time and require costly replacements, these systems offer a long-term energy storage solution with a much lower total cost of ownership. Efficiency and quick response. Waterless hydro systems boast high efficiency rates, often exceeding 80%. They can also respond quickly to changes in energy demand, making them ideal for stabilizing grids with high penetration of intermittent renewable energy sources like wind and solar. Engineering and economic considerations. While the potential of waterless hydro energy storage is immense, there are still challenges to overcome. The primary engineering challenge lies in designing mechanisms capable of efficiently lifting and lowering massive weights. These systems must be robust enough to handle the stress and wear of repeated cycles while minimizing energy losses during the conversion process. From an economic perspective, the initial capital costs can be high, particularly for large-scale installations. However, as with most technologies, costs are expected to decrease as the technology matures, economies of scale are realized, and more companies enter the market. Early implementations. Several pilot projects and early implementations of waterless hydro energy storage systems have demonstrated the viability of this technology. One notable example is the Energy Vault, which uses large concrete blocks and a crane-like structure to store and release energy. The company has successfully demonstrated that their system can store renewable energy for later use, providing a solution to the intermittency issues that plague solar and wind power. In another innovative approach, Gravitricity, a company based in Scotland, has repurposed old mine shafts to function as the lifting and lowering system for their weights. By using existing infrastructure, they have managed to reduce costs and environmental impact while demonstrating the flexibility of the waterless hydro concept. A key player in the renewable energy revolution. As the world continues to transition to renewable energy, the demand for efficient and sustainable energy storage solutions will only grow. Waterless hydro energy storage is poised to play a critical role in this future. Its ability to provide large-scale, long-duration storage, coupled with its minimal environmental impact, makes it an attractive option for countries and companies looking to enhance grid stability and reliability. Moreover, as research and development in this area progress, we can expect to see even more innovative variations of the waterless hydro concept. These could include the use of different materials for the weights, advanced control systems to optimize energy efficiency, and integration with other renewable energy technologies. The genius of simplicity. The genius of waterless hydro energy storage lies in its simplicity. By reimagining a time-tested method of energy generation and adapting it to modern needs, this technology offers a new way to store renewable energy that is both efficient and sustainable. As we move towards a greener future, innovations like waterless hydro energy storage will be essential in overcoming the challenges of energy storage and enabling the widespread adoption of renewable energy. In the coming decades, this simple yet powerful idea could become a cornerstone of our global energy infrastructure, driving us ever closer to a future powered entirely by clean, renewable energy.